Hey guys, so in the last video we saw how to render a simple 3D cube using OpenGL and using only this vertex array. This is all the information we had about the cube. So we basically defined 36 vertices because a cube has 6 faces and we are splitting each face into two triangles. So that gives us total of 12 triangles and each triangle has 3 points or 3 vertices. So that gives us 36 vertices, right? And we defined all those vertices here in this array. Then we passed it to the GPU. We told OpenGL how this thing is set up or what's the layout of this, and then the GPU could draw this cube for us. But as you could have already understood or seen this thing, that there are a lot of duplication going on here. So what is happening, I can show you with this view right here. When we are defining 36 vertices, each face is made up of two triangles. For example, this face will be made up of triangle 4, 1, 2 and 4, 7, 2, right? So in those triangles, you can already see 4 and 2 are two vertices that are common between both of those triangles. So how can we optimize for this? So if there were like millions of vertices or like hundreds of 3D objects in your game, this will be a lot of duplication and we are spending that much more GPU memory on this. So how can we do this, right? So as I said in the last video that we only define the outer shell of a 3D object to render it. So in this case, the outer shell is made up of 8 corner points, right? The cube has 8 corner vertices. If we could somehow only define these 8 vertices and tell OpenGL how to make up this cube using these 8 vertices, that will solve our problem. So let's see how we can do that because OpenGL is set up for exactly that. For this, we use a concept called indices array or an index array that basically helps us do this. So let's see how that code works. As you can see, first of all, our cube vertices array has gone down from having 36 vertices to only 8 elements in it right now because we are only defining 8 unique vertices that will make up our cube. If we look at it, I have numbered them from 0 to 7. And if we look at this diagram, I have also numbered these points from 0 to 7 exactly like they are here. So it's better for us to visualize. Then we have defined this another array called as cube indices. What this array does, it defines how to make up 6 surfaces of this cube using these 8 vertices. So it takes an index from this array and it treats it as one vertex. So here we are defining that to make up the front face of this cube, which is this face, we need these 4 vertices, right? 0, 1, 2, 3. So we are saying to make up half of this face, like the one triangle for this face, use 0, 1, 2, which is 0, 1, and 2. So it will make up this triangle and then use 2, 3, and 0. So that will be 2, 3, and 0. So the front face is ready. To make the back face, we are saying use 5, 6, 7, which is which are these 5, 6, and 7, and then use 7, 4, and 5. Similarly, we define all 8 faces. So ultimately, we are gonna be needing the information about 36 vertices, but instead of defining them here and duplicating some vertices in this array, because we are gonna pass this array on to the GPU, right? So we are just saving a lot of memory by only defining 8 unique vertices, and we are, of course, we are spending some more memory for this array right here because this will also be passed on to the GPU. But if you look at a large scale application with a lot of 3D objects, this still is very efficient and way more optimized than our original version. So once we define this index array, all we have to do in code is like a couple changes. First of all, we have to pass this index array on the GPU. So we do it exactly like how we passed our vertex array. For that, we need to create this index array on the GPU. Like we create a buffer on the GPU and we store its ID inside GPU ints array ID, exactly how we created the buffer for the vertex array. Once we have that ID and once we start our recording or the VAO layout recording, we pass firstly we pass the actual vertex array and then we select or bind to our newly created buffer which will hold the indices array. We bind to that buffer or select that buffer, or rather let's say activate that buffer, and then we pass this indices array to our GPU exactly like how we passed the vertex array. It's the same function call GL buffer data. Instead of passing GL array buffer here, which tells the GPU that the data that will be passing to this buffer is a vertex array or vertex information. Here we are passing GL element array buffer. So that tells the GPU that the buffer that you have created, which uh, whose buffer ID is GPU ints array ID, in that buffer will be passing the indices array instead of the vertex array. That's how the GPU knows where the indices are stored and how to look at each index and then get it from the vertices array and then draw our cube, right? So here we are passing our the size of the indices array and then the actual indices. These two lines are added to the code, and then another thing that changes is the actual draw call. So originally we were using this draw call called GL draw arrays, and we were passing the primitives as GL triangles, and we were saying we have defined 36 vertices and draw them. But here, what we are going to do is call this GL draw elements instead of GL draw arrays. Our primitives is still triangles because we are still drawing triangles, and we are passing 36 indices instead of 36 vertices. As you can see here, there are 6 faces and each face needs 6 indices. So we are passing 36 indices. If we do that, just that, we have already optimized our code a lot. And if I run this code, you can see it renders the same 3D cube from the same angle. We have just used a lot less of the GPU memory. And this technique will be helpful when you are building like complex applications with a lot of 3D objects. So yeah, this was a short video on how do you use index arrays. And in the next video, we'll see we are gonna have to increase the size of our vertex array from only 8 unique vertices to maybe some more. Because when we add textures in the next video, we do need to duplicate some vertices and we'll see why. So, okay, thank you guys. That's it for this video. I'll see you in the next video.